So I do have, for anyone who's interested, I get a little bit worried. I do have an article I wrote on tankless water heaters. The do's, the don'ts, the why you might like it, why you might not like it. So welcome everybody. Today we're going to talk about RV tankless water heaters. Let's see how it starts. Okay, so my qualification. So in this business, especially if you're a YouTuber and you like to go to YouTube and watch videos and see how things are done, there are so many different opinions, and it doesn't take anything to get online and say, hey, you know what, this is the right way, this is the wrong way to do it. And I've said in a couple of presentations here, and that comes up frequently. In 1986, I became an ISCET certified electronic technician. That's been so long ago that that organization no longer exists. I'm also pretty young tankless water heater certified, Gerard tankless water heater certified. I am NRVIA certified as an inspector, RVTAA registered technician. I have 4 California vocational teaching credentials. I have a California CTE administrator credential, and I actually retired as a vocational school administrator, so I oversaw 12 vocational programs. And the biggest part of this is I'm a lifelong RV enthusiast. So in 1968, my parents bought their first travel trailer. We hit the road and never stopped. I grew up in Minnesota, so we can only camp in the summers, basically. But ever since then, I've been into RVing. 2022, decided to retire. We bought our new Reflection, fifth wheel, bought a new truck. I got into this after I retired, just because I think there's a need to help people understand how some of these more complicated systems work, to answer questions. One of the big discussions right now is tankless water heaters. So if you have a Grand Design and you have a tankless water heater, you have one of 2 options, a Furrion or a Gerard. So in 2009, Gerard came out with the first tankless water heater specifically designed for RVs. 2009 is not that long ago. Tankless water heaters have been around for homes since the 60s, but there are a couple of issues when you put a tankless water heater in an RV that the industry still hasn't quite figured out how to handle, and we're going to talk about that. I picked up 3 similar water heaters that are almost the same, but a little bit different, and 2 of them I tore apart, and there's some parts up there. Because I'm the kind of person that I have to know how something works. I can't fix it if I don't know how it works. So I completely dissect them. Every tankless water heater manufacturer out there will not give you any information on actually how it works, because they say it's proprietary. So we're going to talk a little bit about, probably most of you would have a Furrion if you have a tankless water heater. And Furrion uses this little guy right here. They call it a vortex water mixing chamber. It was kind of an afterthought for Furrion, so they stuck it on the back of the unit. It's great for keeping that water temperature fairly consistent. It's terrible if you live in a cold environment, because you can't just open a drain and drain it. So when these first came out, everybody was having issues. The next spring, they fire up their rig, turn on the water, and they got a water leak. Nobody sells that part. In fact, you can't buy any part except the filter, pressure relief valve, and obviously you get a fuse and switch because they're not specific. Sometimes you can get that air pressure sensor. Anything else on that water heater, you cannot buy. If you don't winterize this properly, if you don't descale this occasionally, you're going to end up buying a new water heater. tankless water heaters in your rigs. So most of you. Let me ask you, show of hands, do you like it?
Do what?
So,
You like it?
quite a few. For those of you who said you like it, did you have a tank type water heater prior?
Yes.
Okay, that's good. So, obviously, a tank type water heater, same thing most of you have in your home. We have a water storage tank, we fill it up with water. We have some kind of heating source, either electric, propane, natural gas, to get that water hot, and then we keep it hot indefinitely. So, it's not exactly efficient because if you, and let's talk about your home right now. If my water heater sits out my garage, I don't have a blanket around it, so it doesn't get cold here, but it gets chilly. Last night it was on the Thursday. So it's going to take a lot of fuel to keep that water hot. So it's definitely a waste of resources and a waste of money to try and keep water hot indefinitely. This guy, it doesn't even think about getting hot until I turn on that faucet. The burner in here is considerably larger because I got to get that water really fast, but much more energy efficient in a home. Not necessarily that way in your RV, and I'll tell you why in a little bit. So, tankless water heater on demand. A lot of manufacturers or a lot of salespeople will call this an instant hot water heater. This is not an instant water heater. Instant water heater is that little thing that you see in a lot of offices sitting on a water cooler. It's actually a tank type water heater that's electric, and it's only that far to get that water to the spigot, so it's pretty much instant. This doesn't have a tank, except for this little tiny mixing chamber. So this is far from instant. This water heater takes 19.5 seconds from the time I turn on the hot water to the time that it's 124 degrees. 19.5 seconds is a long time if you're waiting for the water to get hot at your faucet. Now, and we're going to turn this on here in a little bit, and you're going to see the temperature is going to steadily increase, so it's going to get warm in about 10 seconds. That might be good enough. In a typical RV, you have about 20 feet of some kind of hex line, flexible line, half-inch line between your water heater and your kitchen sink. 20 feet is a lot. It takes 10 seconds at 45 psi in a half-inch pipe to get the water from your water heater to that faucet. You're going to say, you know what, my kitchen's not 20 feet from the water heater. Crawl up underneath there and look and see how that hose goes around and who knows where. So on demand, not easy. All right. High energy efficiency for tankless, low energy efficiency for the tank type. The biggest benefit to a tankless water heater is that I can turn this on, and as long as I have water and propane, I get hot water. So on my demonstrator, I have a 10-gallon. This is actually something that you would see in like a van conversion. It's an actual water tank for an RV. So I have 10 gallons of water. I can turn this on and let it run until all the water in this tank is 124 degrees, and then I'm not even heating the water, it's just circulating. But it will never end. It's always going to be hot. I like to take long showers, even in my RV, and then my wife gets up. Our previous fifth wheel, we had a 10-gallon water heater, and my wife was never happy with me because you're going to run out of hot water. So big advantage for this thing. Complex technology. So a tank type water heater is really simple. You have a burner, you have a thermostat, and you have a tank. That's it, right? We have some safety devices so that if that water gets too hot, it's not going to explode. We have a pressure relief valve so that it can blow off any pressure. But they've been around since actually it says in my paper, 18, virtually unchanged. So the tank type water heater in your house hasn't changed in well over 100 years. Where this, again, this came out, not this specific one, but the first one in 2009. And they made some really big improvements, but to do that, the technology has really gotten complex. So there are multiple temperature sensors and multiple safety switches and pressure regulators, and if you have a tankless water heater in your RV and you've never seen a code, you are really lucky, because typically you're going to get a code that says low water flow, or no propane, no or insufficient air pressure. And we're going to talk about all those things. So normally, you turn the faucet off, you wait a few seconds, code goes away, you turn it back on, and it works just fine. But these are really, really complex, and we're going to talk about what it takes to heat that water. So the chance of this going 20 years without breaking is probably not going to happen. You should get, if you take care of this, you should get 10 years out of it. And we're going to talk about what you need to do to take care of it. So, very complex. The biggest thing is this one is sensitive to water flow. So, like I said, they put tankless water heaters in homes for many, many years. And they're getting to the point where they work very well. I just installed one a couple months ago. And I like it most of the time. What's different about your RV is you're mobile. Every time you move that rig and plug into somebody else's water source, pressure, even if you've got a pressure regulator, I'm going to tell you the pressure makes a difference. The volume of water and the hardness of water are all variables that are going to impact this tankless water heater. So water flow is the biggest by far. So when I get to a campsite, I take my pressure regulator, put it on the spigot. I take my little disposable filter canister, plug it in there. I plug it into my RV. I turn the water on, right? I think that's probably the way most people do it. Some people have, really nice filters, which may be good for keeping your water clean, but may be really bad for this. So everything that I put in that water line is going to impact my water flow. This water heater has to have a minimum of 0.3 gallons per minute before it's even going to turn on. I answer a lot of calls for people that say, hey, I was in the shower, I had this set at 120 degrees, and all of a sudden I got scalding hot water. Insufficient water flow. And we're going to talk about the different things that water flow and water pressure can do to you, but one of them is you get really hot water, because I have a 65,000 BTU burner that I can adjust down considerably. I can adjust it down to about 16,000 on this one. But if I don't have enough water running through these coils, I can't turn that burner down. So this is actually what my heat exchanger looks like. I can't turn that burner down enough to keep this water temperature below whatever it's preset to. And I'm going to demonstrate that. So if you ever have an issue where, you're in the shower, your spouse is in the shower, and all of a sudden it's like, hey, wait a minute, what happened? Did you turn on the water somewhere? The answer is probably that filter needs to be replaced. Your pressure regulator you might need a little bit more pressure. Some of those things restrict the flow considerably. So, again, when I compare tankless to tank type, water flow is just not an issue with a tank type water heater, because it's just a tank full of water. And if you think about a hose or a pipe, as I open that spigot at the end, that faucet, that water's gonna move through there. It might just trickle at my kitchen sink, but it's still the same temperature water. If I do that with this guy, I'm either not gonna get hot water because it's not gonna turn on, or I'm gonna get really hot water, or I'm gonna get water because it's really hot, then really cold, then really hot, and really cold. So water flow is a big deal. I hear from people all the time, hey, I love my tankless water heater because I never have to do anything to it. No, that's absolutely not true. So tank type water heater, unless you have an Atwood and it's an aluminum tank, you have an anode rod. So every year, you should pull that anode rod out, throw it away, drain the water out of the tank, get one of those little wands that go in there and clean out all the scale and the buildup, put in a brand new anode rod, and you're good for the next year. So tank type water heater, absolutely. And I'm gonna tell you, there are people in here who will say, hey, you know what, I've never touched the anode rod in my tank type water heater. You should, because that's a sacrificial piece of usually magnesium that when you constantly heat water, it's gonna try and rust the inside of your tank out. So instead of destroying your tank, it's gonna destroy that anode rod. So if you don't replace it, if you have a tank type water heater and you don't replace it every year, you should. You just should. It'll make that water heater last so much longer. So in this one, there is no anode rod. There's nothing to be concerned about with rust inside that tank. It's not, there's nothing steel. Everything in here that touches water is copper. And this copper will last a long time. The problem we have is with calcium and scale. So I'm going to pass one of these around. Let's start over here. This is our water flow sensor. I want you to look through that. You're going to see some impellers in there. Go ahead, pass it around. So as the water flows through this, and it's located on this side of this one, on your carry-on, this is right here. Those impellers spin at a certain rate, and it tells the control board how much water flow you have. Now, one of the reasons I like this as my demonstrator is I can see exactly how much water flow I have. So if you look through that and you think about an area that has hard water and scale buildup, those impellers are extremely sensitive to anything sticking to them, and they're plastic. And eventually they're just going to stop turning, or they're not going to turn at the same rate that control board thinks it should. Every year, at the very least, you need to descale this. Not an easy process to descale your water heater, because you have to get to the back of it. And you have to take off the 2 lines, the hot and cold water lines, and then what you're going to do is take a 5-gallon bucket. You're going to put about 4 or 5 gallons of 5% white vinegar in it, and a submersible pump, and you're going to pump it into the cold, come back out the hot, go back into your bucket. You're going to let that vinegar run through there for an hour. Now you can get some tablets, some powder that it'll descale in about a half hour, but hey, vinegar's cheap, right? Go to Smart and Final, get 4 or 5 gallons of vinegar, and run it through there. If you don't descale this, you can void the warranty. You can certainly have a lot of problems, and you're not going to get the life out of this water heater that you should get. Again, if you did that once a year, you should get 10 years out of this water heater. That little flow sensor right there, if I could buy an aftermarket one that actually fit in my Furrion, they cost about 30 bucks. You can't buy it. Furrion will not sell that to you. So for a $30 part that got scale buildup on it, calcium buildup, you're gonna have to replace that water heater for 800 bucks. So if you were to come over to site number 78, I could show you on my water heater. I actually put 2 of these on the inside of my water heater, and I did the plumbing put a couple of valves so that I can change the water flow, and I can come in here with my vinegar, come back out here, so I can descale my water heater standing right outside. The only thing I have to remove is the cover off my water heater. I really like that because I'm old and fat and I can't get down there to crawl in behind my water heater. So how many of you have seen the backside of your water heater? Is it easy to get to? Do you want to crawl up in there and disconnect these two hoses and hope you don't break that plastic fitting and descale this thing? Do you want to do that every year? Because I sure did. So if you want to see how I did it, I'm more than happy to show you. But this is exactly what I did on mine. And I came out inside of the case, inside my water heater, two little 90-degree elbows. I can plug my hoses in, pump the vinegar through there for an hour, and I'm good to go. I teach this class to people who want to do all the maintenance on their rigs. I teach this class to people who are brand new to the RV world, and when the salesman says you have an instant hot water heater, and they call me up and say, why does it take 30 seconds before I get hot water at my kitchen faucet? I'm going to explain it to them. So that PowerPoint is more about getting really into how this heat exchanger works. And we're going to talk a little bit about it. But let me show you our burners. So this is a typical burner assembly for a tankless water heater. This is the same burner assembly that they use in a Furrion. It looks a little bit different, but there are 5 burners in here. So when I first turn on my hot water faucet, this thing is going to come on at 65,000 BTUs. All 5 burners are going to light. I have what's called a proportional flow valve that's going to adjust how much propane it sends to it. It's going to send the maximum amount of propane to all 5 burners. Then we take this fan, which sits on the top, and our heat exchanger is going to sit between here, and we're going to blow air out, which means we're going to pull the air in from the bottom of this heat exchanger. So think about a convection oven. You take an oven, you apply heat. If you want to get it hotter and cook faster, you blow air across that heat. So that's what this is doing. We're pulling air across the burner assembly through the flue on that heat exchanger, and we're superheating that air, and then we're running water through that superheated air. So when I first open my supply valve, I don't know if you guys will be able to see. There, this thing lit. So why the delay from the time the water started to flow until my burner actually lit? So remember, I'm getting cold water. I'm getting cold water into this thing that whole time. So that was about 5 seconds. The reason is, the first thing that happens is that flow sensor has to detect a minimum of 0.3 gallons of water flowing through. So if I just open this valve a little bit, it's not going to light, right? So if I'm taking a shower and my shower head's all clogged up and it can't get to that 0.3 gallons, the water heater's never going to light. So once that flow sensor detects that 0.3 gallons per minute, the second thing that you should have noticed is this fan comes on. Now it's over there. There's a switch and a little hose that goes to this fan assembly. So until the control board detects the proper amount of air flow going through that heat exchanger, it's not going to light. So we got to get the water flow, we got to get the airflow. Then we're going to check input and output temperatures to make sure that they're not above what this thing can run on. And yes, input temperature is important. So keep that in mind. Mainly output temperature, because if this thing gets above that 124 degrees, it's going to shut down. I have this set at 124. I leave this at the max for my demonstrations. So water flow, airflow, check the temperature incoming and outgoing. Then let's light that burner. And then let's wait a good 5 seconds for that heat to actually get to the water going through this. So on our heat exchanger, we have a water coming in here. It wraps around 3 times. So this heat exchanger is getting really hot because we have 65,000 BTUs heating this thing up. The water going through the tube on the outside is preheating the water. It's the tubes on the inside, kind of hard to see because we have all these fins. So this is like a radiator in your car, working just the opposite. In this one, instead of cooling the engine, the coolant, we're heating the fluid that goes through here. So most of this heat exchanger is empty. It's a fluid. So we're sucking that hot air across these coils. So if you look at how much piping there is, and I haven't actually measured this, I'm gonna cut one of these apart and actually measure how much water this holds. You gotta get a lot of water through here before you even get the water inside that heat exchanger. So we got our cold water coming in, going around, then finally going through. So again, 19.5 seconds to get that up to full temperature. All right, once that happens and that heat exchanger gets really hot, now we have to lower that flame because this is going to hit 124 degrees. We don't want it to shut off. We don't want that temperature to go above that because we're going to get burned in the shower. So we have to now adjust our flame so we can turn off these 2 burners completely, and then we can lower these 3 down to a much lower flame. So again, air flowing across here, having the appropriate flame, and then making sure we have enough water going through here is critical. I want to show you the bottom of this burner assembly. There's a grid on here with tiny little holes. If you want, I can pass this around. I don't know. But we're pulling a whole bunch of air through that grid. It's kind of hard to see. Maybe turn it this way. This is that burner assembly. There is maybe 3/8 of an inch between that burner assembly and the bottom of this. We're pulling, if you hold your hand over this, you're going to see there's a lot of air coming out of that fan. We have to get that air in through the bottom of that. So what happens if, I don't know, a mouse decided to build a nest in here, or you had some kind of insects or varmints or something, dust, that is going to block that airflow. Those holes are tiny. So if you don't get underneath there and make sure that that's clean, that airflow from that fan isn't going to be right. So people call me up and say, hey, I have a code, and it specifically says that it's my airflow sensor. Might be. That airflow sensor is really simple. Can't buy it. It's, again, it's a $12 part. You can't buy. But I'm going to tell them to get them here, see if you can get underneath there, and see if that's clogged up. So maintenance, critical on these. You want to make sure that you're getting air through the system. When this is running, I can put my hand over this, if I had a glove on, because it's going to be really hot air, and I can get this water heater shut down just by changing the airflow. So again, water flow, airflow, they're critical. So let's talk a little bit about some of the conditions that are going to cause inconsistent heat. Water flow. So we already talked about that regulator valve, that filter, maybe the size or length of the hose that you have it connected to. So I see people all the time that have 50-foot hose, maybe blue, and I don't know, maybe they could have got by with a 15-foot hose. But it's coiled up. I was in Arizona about 6 months ago. It was hot. It was 125 degrees outside, and my neighbor had a black hose. I don't think it was water safe, but it was a 50-foot hose, coiled up, direct sunlight, right next to his RV. It's kind of like, okay, I hope you don't have a tankless water heater, because remember, we have a sensor that's going to read that input water temperature. So if it's sitting out there in 120-degree weather, direct sunlight in a black hose, do you think that water temperature is above 120 degrees? It's never going to turn on. You're going to turn on his hot water faucet. Actually, there's going to be some water inside the RV that's probably cool because he's got his air conditioners running. It might fire up, but as soon as that hot water from that hose gets to that sensor, it's going to say, hey, we detected an error. Incoming water temperature is too hot. Shuts off. 50 feet of hose, with a 3/4-inch hose, it's going to take a long time to eventually, that groundwater is going to be maybe 70 or 80 degrees, cool enough where that water heat is going to turn on, then he's going to get hot water. That's probably, I don't know, 5 gallons of water later. So he's going to see it's going to come on for maybe a few seconds, it's going to turn off, but he's going to have really hot water because it's coming out of that dark hose, and then all of a sudden he's going to get cold water. So, situation where your hose, if you have a tankless water heater, my suggestion is try and keep that hose up under your trailer if it's really hot outside. Try and keep it out of direct sunlight, or you're going to notice a fluctuation in temperature. So again, if we have restricted water flow, so let's say we hit that 0.3 gallons per minute for a little bit, and typical shower head, that's probably not an issue unless it's plugged up. Some of them that have different spray patterns, you can get down to 0.3 pretty easily. But let's say the water heater did fire up. It gets up to, in this case, 124 degrees, but it just keeps going. 134, 144, 154. You're standing in the shower and you've got your hot water valve all the way open and your cold water valve cracked a little bit because it's comfortable, and all of a sudden you get burned and you keep bumping up to cold water. What you're doing is further restricting water coming through this water heater because you only have so much volume coming in. So if I have the hot wide open and my cold open a little bit, I'm restricting what goes through here. It's going to make the problem worse. So you're going to have to keep opening that cold water. All of a sudden, you're going to freeze because you just dropped below 0.3 gallons per minute. The water heater shut off. Everything that's coming through the system now is cold water, right? Instinctually, you're going to turn that cold water completely off. The water heater is going to light again, and you're going to go through that same process. The way you should use your hot water heater, and a lot of people do not want to do this. If you read the manual, it says only use hot water. It'll say that because I can adjust the temperature down to something that's relatively comfortable, 99 degrees. I can take a shower and never turn the cold water. I have full volume. But I have full volume going through the water heater, so once this thing stabilizes, it's going to stay at that 99 degrees forever. And I'm going to tell you, I run this thing until the water in that tank is at 99 degrees, and it stays very, very So it's going to tell you, get in the habit of lowering the temperature to what's comfortable and only use hot water. Great idea. So my wife goes to do dishes, or I go to do dishes. I want hot water in the sink. So, I don't know. I hate going in the bathroom and adjusting the temperature every time I want to use a different faucet. That's the way you should do it. What I did in mine is I put in a different shower that has more flow. So on the Furion, you can't see what your water flow is. It's not on the display. So I actually use a water flow meter, and occasionally I'll plug it into my hose. So after my radiator, after my filter, plug in a flow meter, and I'll go in, turn on my shower, hot water only, hot and cold water, and I'll just go out and check the flow. I want that flow to be about 0.5 gallons per minute. So if I need to change my filter or I need to clean my shower head, I know that's my problem. But again, if you're okay with, and I do talk to a lot of people that adjust that to 98 to 100 degrees, and they're perfectly happy. If that works for you, by all means do that. So I can show you later how you can do this. So right now, with this is a 1.5 gallons per minute faucet. I have 1.5 gallons per minute. If I open the phone, and I have 0.7. So you don't believe that this changes the volume. I have a high volume water pump. I have a short distance. I'm not pulling it, from a spigot and through a hose and through everything else. But I went from 1.5 gallons per minute to 0.7 just by opening both of these valves. So if you have that situation where you're getting burned in the shower, try it. Try adjusting that. Just use hot water. All right. This water heater and the Furion water heater has the capability of heating 3 gallons per minute. That's a lot of water. The Girard, so Grand Design started putting Girard water heaters in some of the smaller units. The Girard can do about 2.8 gallons per minute. Works great. You saw when I turned this on, I was at 1.5. Half of the capacity. What if you have kids, you're standing in the shower, you're running, let's say you're running both. You have hot and cold water, and we're at about 0.8 gallons per minute, still above the 0.3. And then the kids, they've been playing in the mud somewhere, and they decide they're going to use that outdoor shower, and they turn it on. It's probably going to keep consistent because we can go up to 3 gallons per minute, and this thing is going to keep the water hot. But then your spouse is in the kitchen and turns on the hot water, and bam, everybody gets lukewarm water. So that heat exchanger can only heat that water up so fast. So if you get above 3 gallons per minute, all of a sudden you can't keep up. So remember I said this thing will give you hot water forever as long as it's above that 0.3 and below 3 gallons per minute. In a situation like that, yeah, you just say, come on guys, don't turn on the hot water when I'm in the shower. So again, too much water, too little water. Let's talk about too much air. So see if you can hear the difference in this fan when I turn this off. The fan right now is on low. When I turn this off, the fan's on high. So this fan does two things. It heats the water and cools the heat exchanger. So if I'm pumping 0.3 gallons per minute through this, that fan is going to go on high that fan is going to go on low because the more hot air I throw across this heat exchanger, the faster it's going to heat that water. So that fan is going to stay at a really low rate. If I get up close to my 3 gallons per minute, that fan is going to come on high because I want more air to try and heat up that heat exchanger. So one of the other issues that I've seen on these are these fans not going either high or low. And there's nothing you can do. Usually it's the control board and the way it senses the pressure. But again, you replace the water. Coming from a tank type water heater, so I typically do the dishes. And I was in the habit of, especially if we're boondocking, might wash a couple dishes, turn the hot on for a second, rinse them, turn the hot back on. If you do that with this water heater, are you ever going to get hot water? Maybe if you turn it on for 39 seconds until the water gets hot. As soon as you turn it off, the flame goes out. Turn it back on just for 2 seconds. What happens? Cold water comes into this, goes through that heat exchanger. So by the time this thing lights again, you've already sent a half a gallon of cold water through the system. So you're never going to get consistently hot water at the sink. My answer to that: rinse the dishes with cold water. It works. I've talked to people that boondock all the time. Absolutely love this. And what they do is they have a bucket, put it in their sink, rinse with that hot water and leave it running, and then take that hot water and set it aside and use that to flush their toilet. Hey, you know what? That works. Most people that boondock with a tankless water heater, their biggest complaint is you're going to go through a lot more water, right? It takes, and that article will explain why, it takes 10 seconds to get hot water to your kitchen faucet with a tank type water heater. It takes 29 seconds with this. That's a lot of water. So instead of, I think it's like 0.2 gallons of water, you're now going through 0.59 gallons of water. If you're in a place like this and connected water, connected to sewer, the only limitation is how much propane you have. So, I don't love it, but I like it. How's that? Anybody got any questions? I know I talk a lot. I was a teacher.
I have two questions.
Uh-huh.
Would you have a suggestion of what we